Okay, this is part 2 for section 5.5, theorems about roots of polynomial equations. And just to mix it up a little bit, we're going to start off this section of notes with a joke. All right, here it is. What do you call a bird that doesn't eat? Are you ready? A polynomial. Polynomial. Get it? Pretty clever. All right, so we're going to start with a conjugate root theorem. Now let's review what a conjugate is. An example of a conjugate would be x plus 3 and x minus 3. Okay? A plus b, a minus b. Those are all conjugates. So this theorem has two parts. First part, it says that the polynomial has rational coefficients. Then the irrational roots occur in conjugate pairs. Basically, if a plus the square root of b is a root, then a minus the square root of b is a root. Second part, it says that the polynomial has real coefficients again, then the complex roots also occur in conjugate pairs. Remember, complex numbers are those negative numbers underneath the radical. If you remember, the square root of -1 is I. So going back to this theorem, it says basically, if a plus bi is a root, then a minus bi is also a root. All right, example 1 says write a polynomial p of x with the given roots, -10 and the square root of 5. Now, if you remember from the conjugate root theorem, that if the square root of 5 is a 0, then so is negative square root of 5, because those are conjugates. And anytime you have radicals or imaginary numbers, you're going to have the conjugate pairs. So we really have 3 roots. So we're going to go ahead and write this as x plus 10, x minus the square root of 5, and x plus the square root of 5. And then we FOIL. And if you remember what happens to conjugates, the middle terms will add up to 0. We'll go ahead and FOIL the last two, x minus the square root of 5 times the quantity x plus the square root of 5. And I'll FOIL it all the way out just so you can see this. You end up with x squared plus x square root of 5 minus x square root of 5 minus square root of 5 times the square root of 5 is the square root of 25. You notice here our middle terms are opposites, and they're always going to be opposites when you have conjugates. So you get x squared minus 5, because the square root of 25 is 5. So when you do conjugates in the future, you don't really have to multiply the outer term and the inner term, because they will always add up to 0. You just need to worry about multiplying the first terms and the last terms. Okay, so now we need to FOIL x plus 10 times x squared minus 5. And you get x cubed minus 5x plus 10x squared minus 50. We have no like terms, but we do need to write it in standard form, and we do need to call it p of x, since that's the name of our polynomial. So when I go to write my final answer, it's going to look like p of x equals x cubed plus 10x squared minus 5x minus 50. And we're done. Example number 2, it says write a polynomial p of x with the given roots, 4, square root of 7, and negative 3i. So looking at it first glance, it might look like we just have 3 roots, but we have a radical. So we also have the conjugate of that radical as also a root. So this is going to be negative the square root of 7. And we also have an imaginary, so we have the conjugate of those. So the conjugate of negative 3i is positive 3i. Kind of think of conjugates as opposites. So when we're starting out with 3 roots, we really actually have 5 roots. We're going to have 5 factors that we need to FOIL together. So we're going to write x minus 4 times the quantity x minus the square root of 7 times x plus the square root of 7, x minus 3i, and x plus 3i. Now this may look bad, but if you remember when you FOIL conjugates, the outer terms and the inner terms always add up to 0. So that'll help us save some work. You really only have to multiply then the first terms and the last terms. And I'm going to go ahead and start this polynomial with you guys, but you're actually going to finish it. So let's go ahead and FOIL these two together first. And they're conjugates, so really I only need to multiply x times x and negative 3i times positive 3i. Well, a negative times a positive is a negative. 3 times 3 is 9. I times I is I squared. All right, now let's go ahead and multiply this set of conjugates together. X minus the square root of 7, x plus the square root of 7. And again, we only need to do the first terms and the last terms. So this will look like x times x. And then negative square root of 7 times positive square root of 7. And that'll be negative square root of 49. And then the x minus 4 we just write. All right, let's go ahead and simplify it. We have x minus 4. Square root of 49 is 7. And if you remember over here, I squared, if I equals the square root of negative 1, and then I squared is just negative 1. So this really becomes negative 9 times negative 1 becomes a positive 9. All right, now this should look like something we've seen before. Your assignment. When you come to class tomorrow, I want to see that you have finished this example. And I will be checking, and you will get points for this, okay? So if you have any questions on it, make sure you come see me before class. Good luck.